Hey, this is Remu here. Stream number 16. Alright, this is probably going to be a short stream because I started kind of late and I really just want to get this done tonight. So verify the RAM usage that firmware is currently using, and then place the heap in memory properly. Properly, as in not improperly. Okay. This is all done in heap.rs right now. I'm hard coding the heap to start at this address and go to this address. And here's our memory map. So we have RAM starting at this address for this length. Handy dandy calculator. 264 times 1024 hex. So we have RAM out to 2004 2000. Hey there, Endoran. How are you this morning? Okay. Pretty sure our stack is placed for us at the end of RAM. So question is, how much RAM do we want to allocate? If RAM ends at 2004 2000, then that means I only reserved like maybe a quarter of RAM for the heap. There's probably a quarter unused, and the other half is all for the stack. Bit tired. Hey there, the tattoo technologist. Howdy. So I've seen other people's firmwares where they do this a little bit more intelligently. Rather than hard coding where their heap is, they actually take a look at what the linker provides. And so I want to do the same thing. So I am going to do that. I think I was going to track down, if I can, click on one of these guys. Not this, but like within the Cortex-M source. I think there's a linker script here somewhere. Maybe it's not in Cortex-M, but in Cortex-M... No? Cortex-MRT, maybe? Yeah, here we go. Link.x.in. Here we go. Intelligent is for the smart people, so not you. Come on, Endor. Don't sell yourself short. Somewhere here is going to be a RAM section, right? S heap? Start of heap, maybe? Oh, what? I don't want the feedback hub. The heck? Oh, I still have my keyboard in a different mode. Okay, here we go. Ugh. Heap. Start of heap. Okay. So there's start of heap, but there's no end of heap. E uninit. Okay, so this is what, uninitialized RAM. And there's the end to it, and this goes in RAM, and then wherever that is where the start of our heap is. Okay. So then I guess it just becomes a question of how much memory to allocate for the heap, and then the rest of it goes to the stack. I kind of feel like verifying first where the stack is. The only way I know how to do that is to inject some assembly to like get a copy of the stack pointer. Where would be a good place to do that? Maybe in... Yeah, in heap init. Like... Well, no, hold on. Why not just do it when our keyboard starts up? So in run. Anywhere here, right? Maybe even in new. I thought I logged something when the firmware booted up, but I guess I didn't. Let me try to figure this out. I'd like to confirm where our stack is at this point. So it'd be in a safe block, right? And then an ASM block. I forget the syntax of this though, so I think I'm gonna cheat and look at my other project where I've done some hard-coded assembly. I gotta be careful because I have to do this in thumb instruction set, right? Not in ARM instruction set. Okay, so looks similar. Wasn't there... Didn't I have like a script to look at the disassembly? Or I had it in my README here somewhere? Yeah, it was this disassemble all cargo object dump. That's what it was. But I have to change that a little bit. I gotta put nightly in front of... Actually, I don't need to put nightly in front of it because nightly is now the default, right? But I do have to say beep beep. Wait, what? What's happening to my command here? Copy. Paste. Beep beep. How come it's overwriting rather than... Can I go back and then... There we go. Now it's working. Rusty keyboard. Okay. I want to look at this disassembly for ideas. Failed to parse metadata. Failed to parse metadata. Why would it say that? Failed to parse metadata. Did I damage something here? I did. Okay. Okay. Just by adding that, I damaged it. Let's just comment it out then. I've never seen it fail but not say why like that before. I misspelled disassemble. Disassemble? Alright, so here's some thumb assembly code, right? Beep beep. Beep beep. There we go. So actually, this is the second stage bootloader. I'm wondering at what point are we going to see it set up the stack pointer? Actually, it should be setting it up right at the front. Actually, it should be setting it up before the second stage bootloader. So we're not going to see it actually set up the stack. Search for SP. Okay, here we go. Beep 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 beep. Beep 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 beep. Okay, I feel like I should get rid of that sound. It's really annoying me now. I guess I could just move the stack pointer into a register that's tied to a return value, and then just read it out that way. I know that traffic is annoying, isn't it? So where have I done this before? I guess I could search for ASM. Okay, this is to how to get it in. How do we get it? How do I get something out? That's how I get it out. But I guess instead of underscore, I would put a variable name. Maybe I should look it up. First inline assembly. Okay. Our print type in, out. Expression must be a possible initialized place expression which the contents of the allocated register are written at the end. Okay, so we just make a mutable variable and then it gets assigned to that? Okay. So like let mute stack pointer. Pointer. Do I need to give it a type? U32 is good enough, right? Move. It's destination and then source, right? So it would be stack pointer SP equals out reg stack pointer. See if that builds. Failed to parse crate metadata. Oh, I have to import it. Core Arch or Cortex M? Good question. I don't know. How about Cortex M? No, that wasn't it. Core Arch? That worked. Okay, and what is it going to tell me I'm not using it? Okay, great. So it should build, but with the warning that we're not using it. So let's just do an info. Stack pointer. Let's get it in hex. That's like :08x, right? Okay, and then let's program it. Oh, the connection delay again. Okay, while we're waiting for that, I guess working on the next thing. Oh, so I guess I don't need that assignment. Anyway, I guess the next thing would be try to use the heap symbols. I did this in the other project. Let me see what I did here. So in this linker script, I had BSS end and BSS start. How did I do this? Right. So we just made a symbol, and then we would take a mutable reference to it and an address of it, and oh no. Right, if it's a value, we do address of that as a usize, and that for some reason that gives us the correct number. Okay. Let me just copy this stuff. Okay, there we go, stack pointers. So it is in the end of RAM, right? Thought it was 2004200, so we're using whatever 2000 hex minus 19B4 is. That's how much of the stack we're using. It would be cool if I knew how much, like, I need to reserve for the stack. Maybe I just, for safety's sake, just use like half, like all the way up to half of RAM for the heap and the second half for the stack. So that would be 2000 up to 2002 roughly, or 20000 for the heap. That's twice what I'm using anyway, right now. Okay, so paste that stuff there. These symbols come from the linker. Okay, and the one I was looking at was this S heap, start of heap. Hold on. Oh, I'm in the wrong project. Okay, if it's a position, then we're taking the... its address is the thing. Okay. And then how's... so... what? This is the same thing? Here it's just a number. But then for some reason I'm doing the address of it. I guess the linker just deals in addresses, right? Okay, so then I want that just there. And this symbol comes from the linker. So this is the start of the heap. Okay, so then it's that as U32. Okay. Heap start. And we'll change this from heap start and end to heap size. Actually, why don't I just have it go all the way out to the heap end and it be that. So then this just goes here then. Okay, address of comes from core pointer. Okay, so I need to move this out to there and remove that, put it there. Okay, and I don't need that. Okay. I'd like to copy this again and just to print it out here. Like this, and then we'll just print it out. Heap start. And I missed this last time. This should just... we'll print a 0x in front. does this has to be outside of my input keyboard, doesn't it? Just put it up here for now. Build it. Wait, it's unused? Oh, indeed. That was a bug. Warning message is helping me again. Let me fix that one too. Although it doesn't really matter. I think I just do that, right? Here goes nothing. Cool. So now we see the start of the heap is, so that tells us exactly how much static RAM we're using. 24C in hex. So I'm using 588 bytes of static RAM. Cool. And we're allocating our heap based off of that, so we're making use of all of the memory between the heap start and the end of RAM, dividing it between the heap and the stack roughly in the middle, right? Because if our memory is okay, it's not shown here, but if the top of the stack is at 2004 and I say go to 2002, then that's like roughly half. A little bit less than half goes to the heap and the rest goes to the stack. Cool. So now that we have that, we can clean this up, right? I don't actually need this stuff anymore. Okay, and then that means I can delete all this stuff. Cool, I like it. That was easy. Build and program one more time. Oh, what happened there? We had like, hold on, let me make sure this program's correctly. Yeah, anyway, do we have two messages step on each other here? Oh, we did. We had left and right simultaneously writing to the ring buffer. That shouldn't happen, actually. Why would we see this? Why would we see this message here? This is from the left board, right? Oh, I guess we were overflowing our ring buffer. It's a weird character there. It looks like a smiley face. Okay, and still operational, correct? Yep. 3, 4, 5, 6, A, B, C, D, E, F. All right. Huh. So added address of a non-null. Remove the heap start because now we're getting it from the linker. Okay. Actually, where did I use non-null? Oh, I was using non-null before, now we're just using address of. Okay, never mind. Oh, I don't need this one, right? So beep beep. Discard that one. Hey there, Metro. I just dropped 201 frames. Plus of the Thursday stream. It's gonna be a short Thursday stream. In fact, I just dropped another. Up, dropping more frames. Dropping more frames. Dropped another 50 frames. 51 frames. It's gonna be a short stream because I started really late, and my goal today wasn't that much. I just wanted to verify RAM usage, which we did. We're using about 600 bytes of RAM statically. And I wanted to place, so I can cross that off. I wanted to place the heap in memory properly, which now we're doing. Based off of the linker tells us where the heap should start. Yay, we did stuff. So git commit, place the start of the heap where the linker says. Okay, I got extra time. I got that done really quick. 26 minutes. So I got some leftover time. So what should I do? Maybe look for some refactoring opportunities? Or look and see what should I be doing next? Maybe key modifiers. Maybe I should be working on that. Like make one of these a shift key. That'd be something that might be interesting to do. Maybe. So what if I make this, well, that's the first one. 1, 2, 3, 4, 5, 6, right? What if I make this one a shift key so I can do shift and then A, B, C, D, E, F? That might be fun to do. It is Friday for some of us. It's Thursday for others. Depends if which continent you're on. Does you drop frames every time I reset the keyboard connection? No. I think it's whenever my son dies in whatever game he's playing. Just kidding. I think it's just totally random at my internet connection. Who knows? Right. Keyboard. Scan keys, right? Okay, so let's play around with the modifiers here. Let me see, where do we actually generate the keyboard stuff? This is where we do, right? Push input. Right. Yeah, so we have these key codes, and these we aren't using yet, right? I think it's modifier that we want to try to use. So that's in this keyboard report. Here it is. So right now they're always off. So let's just define modifier at the top. So let mute modifier equals 0. And we'll do, that's column 0, column 1. So column 0 for the left board. And think about it, it would be this one, right? So instead of adding a key code, well, it would be either or, right? If self.receive greeting, then it is a key code. Else, it's a modifier. And we'll do or equal. It's a really nifty little glyph there. I had this written down here somewhere, right? So notes, aha. So page 60 of the USB HID spec, right? That links? Yes. Well, those are the scan codes. I really want to get the HID spec. Oh, do I not have it linked here? Oh, where did I put that then? Where did I put the HID spec? I'll go find it. Do I have it on the desktop? I do have the zip file for it. It's weird. Why do I have the zip file, but I don't have the... Okay, anyway. I don't know what that is. I'm confused because I thought I had it on the desktop somewhere. Where would I have put it then? Oh no, it's there. Why does it not show up in my Finder? That's really weird. Okay. Here it is. Oh, that's CDC. Shoot, I need human interface device. Where did I put it? Huh. I must have like deleted it or something. Where would I put... Did I put it in here under data sheets? No. Hold on, I think I might have put it in my private notebook. That's the problem. Yeah, I put it there. I put it here. Yep. Okay, so let me open it. This one. And put it back onto this. And close it. Okay, human interface. So we're, it said, what did my notebook say? Page 60. Okay, page 60. Page 60. $60, $57, $59, $60. Okay. Okay, so modifier keys. This is the output report. Yeah, but what are the bits of the modifier keys? Here they are. So right alt. Okay, this is just an example, I guess. Shift, Control, Alt, and GUI keys. You would think that they would actually just have a list somewhere. Here it is. So if let's just do left shift. So that would be bit 1. Okay. So bit 1 would be 2, right? Okay. So now if we have this key held down, it should activate shift. Let's see if it does. Okay, so we have A and then shift. Oh, look at that. I got a shift key. Oh, that's just fun. So it shouldn't show up as a keyboard report. Yeah, and we're not logging the modifiers when we show the keys there. That's neat. I like that. we're sending a report about it too, right? So if I use that tool that we had I had a link to, I should probably put it in this project and not keep it in my personal notebook. There's like a keyboard tool. Where is it? Keyboard tester, here it is. Courtesy of QMK. So if I hold down this shift, oh yeah, look at that. Control minus. I guess, how do I zoom in and out here? Here we go. There we go. Fixed it. So reset. So there's, you can see when I hit shift now. So shift A. Neat. All right. That was easy. I was expecting a sticky keys pop-up. Eventually, right? Indeed. So modifiers are easy. We got that, right? I got to start thinking about what we want to use the second core for. Right now it's asleep all the time. If we start using the second core, then I got to be careful about thread safety on any variables that they share. I think the heap is thread safe, but I need to verify that. I should probably do this now, right? I've been putting that off. So let me check this in. This is just oops. How did that happen? Okay, so experiment with modifiers. Make one key shift. Okay, I'm going to look for the word unsafe. We're going to find out how many times do we use the word unsafe. 19 times. This needs to be unsafe. Why? Is it because fetch add is unsafe? Which one of these is actually unsafe? Oh, it's as ref on a pointer. That's unsafe. Okay. We have to keep that then. And that's unsafe because of why? You have to ensure that the pointer is properly aligned. It must be dereferenceable. It must point to initialized instance. You must enforce aliasing rules. I think I am. Arc inners. Yeah, because we're using an atomic U32 in there for the reference count. That's fine. Yeah. Okay, so these two unsafes we gotta live with, and this one too, right? Think so. It lives as long as self is. Okay, so these three we have to keep. How about here? Yeah, that's in the ROM, right? That's in ROM also. ROM table lookup. Okay, so I can get rid of this unsafe by just moving it out. Right? I can clean this up a little bit. There. Reroll. And this has to be unsafe. Why? Because we're manipulating pointers here. Makes sense. Okay, how about out here? I forget, if that's unsafe, do we need to say unsafe here? Yeah, okay. And why did this need to be marked unsafe? Because the trade is unsafe. Okay, so we need those. This needs to be unsafe. Why? It's unsafe operation. Because, is that because init is unsafe? Yeah, it's because init is unsafe. Okay. These have to be there. Nothing I can do about it. You know, with two unsafes, wouldn't it be easier to just mark the whole thing unsafe? And then I can just simplify this by deleting this part. And here, and get rid of this. And then where we call it, I have to mark it unsafe. So, oh, what happened here? Wait, how did... Oh, right. This does change something. This means, so, yeah. I don't want to make that change. This is a guarantee that this really is... that I'm taking this into my own hands, and this should be safe. Okay, yeah. So, that needed to be like that. Okay, here, I'm okay with just saying, yeah, it's unsafe to initialize the heap. And I accept that. Alright, and let me go back to searching. Okay, logger. That needed to be unsafe. Why? Okay, because to mark it send would be unsafe. Do we actually need to mark it send? Looks like I do. Required because it appears within the type arc. And ring buffer writer. And log. Okay, fine. Does it need to be sync though? It does. Okay, so it has to be both send and sync, and we're marking it and attesting that it's safe to share between threads. And why is it safe to share between threads? I don't remember. Okay, maybe I'll have to come back to that one. That's okay. We have to have that. Just added that one in there. What about this one? Alright, this is reading from the staging area. Need that. Okay, how about this one? Commit reprogram is unsafe. Yes. Where I had to put that unsafe somewhere. So that's as good a place as any. And what about here? That's just because of wait, this one I might not need. This is just returning a slice from buffer memory. I don't need to do this, right? I don't need to do as pointer. Can I rewrite this to just slice? Yeah, can I just say some buffer.mem and actually slice it? So this will be sliced from head to head plus length. That's the equivalent, right? And then it's actually safe. this not safe? Can I return a value referencing local variable buffer? Oh, that should... Oh, wait a minute. That's why I need unsafe, because this buffer is actually a ref cell. So we're allowing peeking into that ref cell. Right. So this was a hack. Okay. Do I need that to be in a ref cell? That's for interior mutability, right? Hmm. Okay. None of these actually need interior mutability, though. I'm wondering if I even need ref cell. Because... Maybe push needs it, though. For this is actually mutating that memory array. Yeah, borrow mute. Yeah. There's where we need that interior mutability. Okay, so yeah, this was just a hack. Okay, yeah, I think I do need that unsafe. It is unsafe to do this because we're kind of breaking the rules about this borrow. So this borrow goes away, and yet we've leaked out we've leaked a reference out. But it should be okay as long as when we don't use it past when we do a poll. I should probably comment this then, right? Here we take a risk that the reference we return will remain valid even though we will have released our reference to the actual buffer. It's important not to use the returned reference after any pull. Because it could point past... Actually, what it'll do is it'll point to a stale data that might get overwritten. So it's undefined behavior, I guess. Well, I don't know about that term, undefined behavior, but it would be bad. Okay, so I annotated the one place where I have an unsafe that I really don't want to have, but there's no other choice. Let me comment that. Let me check that in. Also, this could use some improvement, right? What did I do here? I made the entire init unsafe. Okay, let's check that in separately. Mark entire whatever this is called, init, heap init. Okay, and then this one is to just document safety risk in ring buffer. What is this? Ring buffer peak. Ring buffer reader peak. Okay, let's build and program just to make sure I didn't break anything. And then I want to improve the efficiency of the push. Since when I originally wrote it, I was being lazy. This is writing it one byte at a time. I don't really need to do that, right? I could figure out how to do it instead of a loop for every byte, I could do it in either 1 or 2 loops, right? Because the idea is we might push all the way to the end of the buffer and then have to maybe push from the beginning to where we need to go, or we can just do it in one push. Hold on a moment. I need to say goodnight to someone. All right. Okay, so it's if next is going to go past head that we need to do it in two pieces, right? So I guess I can just say if tail plus data length is greater than size. Then we need to do it in 2 pushes, right? Else we can do it in 1. So if where the tail is plus the amount of data we're pushing goes up to size but doesn't go past it, then I can do a copy, right? How do you do a copy in Rust? Like a plain old byte copy? These things are arrays? Or this? How do I go from a slice into an array? Hold on, we gotta look it up. Yeah, goodnight, insert name of child. It's the child that you met, Endurin. So you know who I'm talking about. Alright, so Rust. Copy from slice to array. Copying parts of a slice? Copy from slice? Maybe that's what I want. Using a mem copy, there we go. So this would be buffer.mem tail tail plus data.len copy from slice data, right? Copies all elements from slice into self using memcopy must be the same. There we go. So if it's in 2 pieces, I need to get how much is in the first piece. So len 1, I guess. I'm terrible with names. So that'll be size minus tail. Right? And then we would do this in 2 pieces, right? So I'd go from tail to size, copy from, and then I need to slice the data up to len 1. Right? And then this would go up to data len minus len 1. Actually, we can just say let len2 equal data.len minus len1. Yep, building my own keyboard. This is a prototype small scale. So the second revision of this will be the full size, probably about the same size as my Corn keyboard, so 36 keys. This 12 key one is just like a, because I didn't want to make the full size keyboard right away without first making some mistakes and learning from them. So I already made some mistakes on this, so I'm glad I didn't make the full size one. I saved some money and time that way. Okay, so this should go to up to len2, copy from data, slice from, I guess, len1 dot dot. There we go. Okay, and then this should be, actually I could put it in here, right? No, this should just be tail equals tail plus data lane. Oh, I have to be careful here. What if we overflow the ring buffer? I need to account for that. Well, thank you for the follow. Yeah, so I have to be careful that I don't hit the head. So let me think about this. It's gonna make it actually look more complicated. Is it worth it? Rust standard lib is a nice vectq. No, I can't use standard lib. This is a no standard firmware because we have no operating system. So I have alloc, the alloc crate though. Yeah, because we didn't have vectq, I just opted to make my own ring buffer. Also, it encapsulates some of the unsafe stuff I'm doing here, right? Where the this thing. So yeah, bending a few rules here and there, making my own ring buffer rather than I guess finding someone else's. I remember I tried to find someone else's and I wasn't really happy with it. Copy the algorithm instead of lib. So this is what we could do and I could get away with it like this. If it weren't for the fact that we might overflow the ring buffer. So I don't want to overflow the ring buffer. I think what I need to do is figure out how much I can write and then limit. Instead of using data len, we would use like the actual amount to write. So let's try this. So let amount free equal, and then it depends if tail, well, if head is greater than tail, right? If head is greater than tail, then the free space is just head minus tail minus 1. What if head and tail are equal? Then then it's all free, right? Okay. So this is head minus tail minus 1. because we can't advance the tail to be on top of head because we'd wipe out all the data in there. So if it's the other way around, if head is less than or equal to tail, what is it going to be? It's going to be size minus tail plus head minus 1. So it'll be size minus tail plus head minus 1. I think. Is that right? So if head and tail are the same number, this will end up being size minus 1, which is correct, right? And if tail is like advanced by 1, it should be 1 less, which makes sense because we're subtracting. And if the head moves left 1, or it's 1 I think this math is correct. Okay, so then let amount equal the minimum of free and data lane. Right? Min comes from core compare. Okay, so then I need to use amount everywhere else here. There we go. And then I gotta be careful here. This should be data dot dot amount. I think that's it. Oh, hold on. This should be len1 to amount. Okay, does this look good? So the amount of free space is, if the head is past the tail, then the data in there is wrapping around, and the free space is the last little bit between the head and the tail. So that's head minus tail minus 1, because we can't use that last byte. Otherwise we'd overflow, we'd go back to it being exactly empty. Otherwise it's the inverse of that. The amount we're going to push in is going to be the minimum of the free space and the amount we wanted to push in. Then if that amount would advance the tail beyond the end, we need to wrap it around. So we do it in 2 pieces, right? We first write from up to size, so size minus tail, and then the amount we were going to write minus that first amount. So the first one goes from tail up to size, gets a copy from up to length 1, and then up to length 2 is copied from length 1 up to amount. It looks good to me. If tail doesn't need to wrap around, then it's just tail to tail plus amount, copies from data amount. I think this looks good. So let's build it. And program. The only way to really test this is to like actually have the circular buffers wrap around. Actually, which they do when you program. So this is actually a good test, is to have it program a second times. Program a second time. And if this successfully reprograms again, then that's a pretty good test, because this will wrap around my circular buffer a couple times at least. Okay, good. We didn't break anything. All right. All right, this is now a shift key. I forgot about that. I'm like, how come I'm pressing and nothing's happening? Because it's a shift key. It's not a scan code anymore. All right. Shift A, lowercase a, Shift B, lowercase b. Messed up there. Neat. All right, cool. Wait, what? That was accidental. Okay, let's check that in. So it looks a little bit more complicated, but instead of doing it 1 byte and doing all this logic per byte, we just figure out how much we're actually going to copy, and then we either do it in 2 copies or 1. I like it. Let's check that in, git commit. So this is like optimize. The name of this is ring buffer write or push. Oh, thank you for the follow. Hey there, Baker Staunch. Add unit tests and do cargo test. I do have some unit tests.
That's the first one I did now, okay?
Can I run them from... don't think I can run them from here. Yeah. It gets confusing to run. I have to go to IBC and run them. Oh, wait, no. I have a bug in my unit test. How did that happen? Huh. Well, let's fix that. I didn't know I had a bug in my unit test. When did that happen? Oh, I changed that. And I never ran the unit test to make sure. Huh.
I'll stay on this side, you stay on that side. We stay on...
I actually have some unit tests failing? How is this possible? Decode and encode are all failing. Wait, what? 7? Oh shoot. I remember making this change too. Yeah, this 7 is not a program message anymore. This, oh, it is if I make that a 4, I think. Yeah, now we're just down to 2 fails. Okay, yeah. I must... This is embarrassing. I must have changed some stuff and didn't run the test. Okay. I think it's because I changed the programming messages, that's why. And I never actually... So embarrassing. I never ran the test to make sure that my tests still matched. Okay. Now we're all testing, and I can run it from the top, right? No, I can't because of the no standard. One of my crates is no standard, and whenever you have a no standard crate, you can't run tests. So I have to go into the thing I have tests for and then run it from there. All right, how embarrassing. Git commit fix unit tests that have been broken a while. How do you spell embarrassing? I don't remember how to spell embarrassing. How embarrassing is that? There are 2 R's in embarrassing. Alright. Running out of things to do without having some major amount of time on my hands. I can mark that one off because I looked into that. So, stuff we can do next time. Try to make use of the second core. Handle host sleep. I guess that's... Suspend? I could try to use interrupts. This is more like on the real board I can add an external chip to do like secondary interrupts or GPIO extender. This is a bigger piece of work that I might or might not do. I can work on debouncing, although I'm not seeing very many bounces. Or I can do combos or tap versus hold. That might be fun to do. Or like if I press this button, it actually is a 1, but if I hold it down, it's a shift. Yeah, according to your spell checker, it's correct. Maybe that's what I'll do next time, is tap versus hold, because that involves like recognizing how long you have the key held down for. Yeah, maybe that's what I'll do next time. Alright, yeah, I said before that this is going to be a short stream, and but I did get some work done, so verified the RAM usage, I got the heap properly constructed, and I did a little cleanup. I fixed my unit tests. and I cleaned that up. Well, actually, it looks a little bit more complicated now, but it should be fewer loops and operations. It should be a little bit faster. I documented that. So yeah, short stream. Let's see if who else is streaming right now. What if we raid Grim? I haven't raided Grim in a while. Let's see if Grim is still going to be going, or are they've been going 6 hours. They might be ending soon. I need to check. Okay, I'm seeing an ad. It's either going to be RW Grim or Adam C. Eunice, I think. Yep, have a good one, Endern. Probably be back tomorrow to work on tap versus hold. Another ad. Well, I can just start typing it. If Grim is still streaming for a while, I'll raid Grim. Let's find out. He's still going, so let's raid him. RW Grim is working on Pigeon, I think. Like he usually is. So I hope you enjoy his stream. I'll be back probably tomorrow. And yeah, I think what I'll be doing tomorrow is this tap versus hold, which is a technique for like having multifunction keys. So either if you tap it really quick, you get like a 1, but if you hold it, it becomes a shift key. So I think I'm gonna be working on that tomorrow. Anyway, take it easy. Hope you enjoy Grim's stream. Bye.